Hello everyone, you are welcome to Math Paragons class. Today I will be explaining how you can use the reminder theorem in solving some problems as far as a polynomial is concerned. Now, looking at the question on the screen, which says find the remainder when x multiplied by x plus 1 multiplied by x minus 2 is divided by x minus 1, x minus 4, and x plus 3. So starting this, the first thing we do is to find the actual expression for the polynomial, which has x multiplied by x plus 1 multiplied by x plus 2 and also x plus 1 and x minus 2. So in this regard, so what I will do is to multiply out this expression we have here. So which means I will multiply, I'll still write x, then x plus 1, then x minus 2. So here we'll multiply the first set here is what I've first multiplied. So x times x minus x times x is x squared. X times 1 is x, so I have x squared plus x. Then the second expression, which is x minus 2, will also be multiplied. So here I have x times this x is multiplying this one, which is x raised to power 3. I use the same x to multiply minus 2. I have minus 2x raised to power 2. Then use this x to multiply x. That will be plus x squared. Then I'll use the same x to multiply minus 2. That will be minus 2x. So I will just add them using their like terms. So here I have x raised to power 3. Here I have a minus 2x squared plus x squared will be minus x squared. Here is minus x squared. Then I'm left with just a minus 2x. So this is the function here. We are using f of x because by the time we start dividing this polynomial using our reminder theorem, the value of x will be changing. So that's why we're using what we call f of x, which can actually means the function of x. Now from the first one, from the top there, we're asked to actually divide the f of x by x minus 1, which is the first one, which is a here. So we'll say f x divided by x minus 1. We divided by x minus 1. So this means that we now have to find a function because we are using what we call the remainder theorem. That's what we are using here. So the divisor is actually x minus 1, which is the divisor. So we can actually write as divisor here x minus 1. This is the divisor, which is x minus 1. So what we now do is to find the function. So of course we have x minus 1, which we can actually write as the remainder r, because we're actually asked to find the remainder when it is being divided. So here we have the remainder r equals, these are x minus 1 actually implies that you have x equals to 1 by the time you factorize. Here you have f of 1. So anywhere you see 1 in the first expression for f of x, x, you substitute it, which means that from here we see x raised to power 3 minus x raised to power 2 and 2x. I'm referring to this one, x raised to power 3 minus x raised to power 2, then minus 2x. What we would now do is to substitute it. So we change x for 1. So here we now have f of x equals 1 raised to power 3 minus 1 raised to power 2 minus 2 multiplied by 1. So here 1 raised to power 3 is 1, minus 1 raised to power 2 becomes plus 1, and minus 2 times 1 is minus 2. So when we add and subtract, here means that 1 plus 1 is 2 minus 2, so this is equal to 0. So we got 0 here. Let me just write it under here. Here we have 0. So this is the first one. Now the second part is asking that we also divide the function by x minus 4. So I will still write it here as b, and that the divisor is still the same. The divisor has not changed. The divisor, we have the divisor here. The divisor is x minus 4. So if that's the case, then we have the remainder. Then now looking for the remainder, we write x, which is r, is the remainder. R equals we have f of 4, which is a function. That means whenever we see x, we'll replace it with a 4. So here we have x raised to power 3, that is 4 raised to power 3, minus 4 raised to power 2 minus 2, then multiplied by 4. So, and also one thing you should note, that if it is minus 4 here, your function will be plus 4. If it is plus 4, your function will be minus 4. So this is how you do whenever you solve. It's just like when you have in here, I'm just explaining it up here again. When you have x equal to 4, it's just like you're having x minus 4 equals 0, then x equals 4. So that is how we got f of 4. So we can continue. Here we'll multiply 4 raised to power 3 is 64. 4 raised to power 2 is 16. That is minus 4 times minus 4 is plus 16. Then minus 2 times 4 is minus 8. Minus 2 times 4 is minus 8. So we just move up, add and subtract where necessary. So here we have 64 plus 16 minus 8 is equal to 72. So the remainder here is 72. Now the last one, which is C. For C we have what's it called? C, we have the divisor also. We have the divisor, which is what's it called? X plus 3. The divisor is x plus 3, so x plus 3. So this one also means that you have x equals minus 3. That's what you get here. This one is x equals minus 3. It means x equals minus 3. So the function now will be based on the fact that our x is 3. So we have it as a remainder. So remainder equals f minus 3. So this now means that whenever we see x, we'll replace it with minus 3. So here we have minus 3 raised to power 3 minus 3 raised to power 2. Then we have minus 2 raised to power, multiplied by minus 3. From here we multiply minus 3 raised to power minus minus 3 raised to power 3 is minus 27. Then here we have minus 3 raised to power 2 is 9. Multiplied by the minus sign here is minus 9. So here is minus 9. Also we have minus 2 times minus 3. Here is plus 6. Minus 2 times minus 3 is plus 6. So we add and subtract where necessary. So here we have minus 9, minus 27 minus 9 then plus 6 equals minus 36. So this is what we get when we divide, or this is the remainder on dividing x multiplied by x plus 1 multiplied by x minus 2, dividing it by x minus 1, x minus 4, and also x plus 3. So it is actually easy using a remainder theorem. So join me in my next class as I will be explaining the factor theorem. Bye bye.